Most reactions do not go 100% to completion. In appearance, the reaction stops, i.e. there's no longer any change in the amounts of reactants and products. When this situation occurs, it is said that we've reached a state of equilibrium. Now, if we look at a theoretical reaction, K is an equilibrium constant. There's a value of K associated with every chemical reaction. It is obtained from the expression of the concentration of products over reactants. The concentration of each reactants and products is raised to the coefficient that's associated with the coefficient in the balanced chemical equation. One important fact on K is that pure liquids and pure solids do not appear in K. They are not included. So we're going to practice writing equilibrium constant expressions for a number of chemical reactions. Okay, here's an expression for K on this first balanced chemical equation. We would have the equilibrium concentration of our products in the numerator, and each concentration is going to be raised to a power that's associated with a coefficient in the balanced chemical equation. So again, see, we have products over reactants. In this next balanced chemical equation, you should note first that H2O is in the form of a liquid. So therefore, H2O is not going to appear in the equilibrium constant expression. So we see here K is written the same way as previously, except we ignore H2O since it's in the liquid form. So we have the equilibrium concentration of our products over reactants, and in each case, the concentration is raised to the power consistent with its coefficient, which in all cases for this balanced chemical equation is 1. So we follow the same process with the remaining two balanced chemical equations. And again, we see solids do not appear in the equilibrium constant expression.